Welcome to this class. In this session, we are going to define what we mean by the conic section called hyperbola, and then derive the equation of hyperbola whose transverse axis is along the x-axis. So please follow through. So let's start by defining what we mean by the term hyperbola. So definition. Definition of a hyperbola. So a hyperbola is a set of all points P in the plane such that the absolute distance from this point P to two fixed points, the difference between the absolute distance between 2 points F1 and F2 called the focus is a constant. So I can say this is a set of all points in the plane such that the absolute distance absolute value of the distances, absolute value of the differences between the distances from all points P of X, Y. So the distances from P to two fixed points are called foci. Is constant. So in this definition, these are the keywords. That a hyperbola is the set of all points P, X, Y in the plane such that the absolute value of the difference. So this is a very key. Absolute value of the difference between the distances from P to two fixed points called foci. One is called a focus, is a constant. So if you understand the definition, it will be very easy for us to derive the equation. And so before we do the derivation, let's give the sketch on how a parabola looks like, on hyperbola looks like. So this is a sketch of a hyperbola. So one arm opens to the left, and then another one opens to the right. And then, so this point, we call it the center, let this be C. So C is called the center. And then these corners are called the vertices. So we can call this one V2, we can call this one V1. So these are called the vertices. And then at this point here, we have what we call the focus, call it F2. And then another one here is called it F1. So these are the two foci. And then the distance from V1, V2, this line here, the line V1, V2, or the line joining the vertices V1 and V2 is called transverse axis. This is called transverse axis. And then, so this F1 and F2, each is called a focus, and all of them are called foci. And then these points V2 and V1 are what we call the vertices. And then if you draw a line through the foci, this line joining the arms of the hyperbola, passing through the foci, if we call this one L1, L2, M1, M2, then each of these two lines are called latus rectum. And so this is the center, and then these are what we call the vertices. So these two arms, both of them are what constitute what we call the hyperbola. So hyperbola actually is a combination of all this arm and then this other arm. And so we are saying that if you pick a point, say P, X, Y, then when you measure the distance from P to this F2, and then this F1, then you're saying that the distance from this point P to F2, when you subtract the distance from this P to F1, then you get a constant. So that's what the definition of hyperbola means. So I'm going to use that aspect to derive the equation of hyperbola on the transverse axis along the main axis, along the x-axis. So A, derivation of the equation of a hyperbola center 0, 0, that's the origin, and transverse axis the x-axis. So that's the first thing we are going to do. So this is how we prove we derive the equation. So consider the hyperbola drawn below. So we are going to draw it in such a way that the transverse axis, the x-axis, and then it's centered at origin 0, 0. So let this be the y-axis, and then this be the x-axis. So this is our center. Call it O. And then let's draw the arms of the hyperbola. So this one arm, this another arm. So customarily, the distance from the center to the vertices is A units. So therefore, let's call this point V2, and then this will have the foci, call it F2, call this other point V1, and then call this one F1. So the distance from the center to the vertices is always A units. So this means that the coordinates of this one will be, because it's to the left, negative A0. This one will be A, 0, Distance from the center to the foci is c units. So this will be c comma 0. This will be negative c comma 0. So this is what we have. So to get or to derive the equation, we have to remember the definition of what we mean by hyperbola. And hyperbola, we have said that is a set of all points P in the plane such that the difference between the absolute distances from P to the two fixed points called foci is a constant. So let's pick our P to be on this right arm, but there's nothing special. You can as well put it on the left arm. So let this be our point P. So we can join P to F1 and F2. So this is what we'll have. So join F2 to P, and then F1 to P. So from definition, they're saying that the distance F2 P, the absolute distance F2 P minus the absolute distance of F1 P should give us a constant. So you say by definition. So this is what hyperbola means. So then the biggest question would be now finding the distance F2P is not a problem. We know the distance between 2 points in a plane. Also F1P is not a problem. So the question is, what is the value of this constant? So what is the value of this constant? That's the biggest question to answer. So to get the value of this constant, we say, because we are saying that this P is a general point on the hyperbola, so we can say without loss of generality, let P of xy be at the point V1. And you see, there is no mistake in this because we are saying that P is any point on the hyperbola. And you see, this is the curve. So there's also a possibility that this the point P1 is V1 is also still on the curve. So therefore, if I assume that my P is here, then there's no mistake I'm making. So this to say that now, where there's P, I'll put V1. So I say F2 V1 minus F1 V1. So this distance. And you see F2 V1, the distance from this point to this point. We know that from origin to V1 is A units, and then from F2 to center is C units. So therefore, the distance from V1 to F2 will be C units plus A units. So that will be C plus A. Then minus F1 V1. So from this one, F1 is at this point here, and then this V1. So from center to F1 is C units, from center to V1 is A units. So this distance F1 V1 would be simply given by this longest distance C minus this smallest distance, shortest distance A. So this will be C minus A. So C minus A, and then this means we'll have C plus A minus A, minus is plus A. So this will give us 2A. But remember, the hyperbola is defined by two arms. So remember, this P I have put here, they can as well be the same point P on this other arm, because the hyperbola is made up of all these two arms. So therefore now, second case I say, let, without loss of generality, let the point Pxy be at the point V2. We have negative A, 0, because it's still part of the arm, which makes the hyperbola. So that means that F2 V2 minus F1 V2, that gives us, so F2 V2, so this will be from this point to this point is C units, from this point to this point is A units. So therefore this difference would be simply C minus A. So C minus A minus into F1 V2. So F1 is here, this way I have V2. From V2 to center is A units, from center to F1 is C units. So the distance from V2 to F1 is simply A units plus C units. So A plus C. A plus C. So this will give us C minus A minus A minus C. So C minus C 0 minus A is minus 2A. So therefore, this constant we are referring to is either plus 2A or minus 2A, depending on either we are picking the left arm or the right arm. So therefore, constant in the formula is given by plus or minus 2A. Therefore, if we call this one equation 1, so by this definition, let's call this one equation 1. So you say equation 1 becomes F2P minus F1P equals to plus or minus 2A. I remember the coordinates of F2 is minus C0, and then F1 is C0, and P is XY. So F2 has coordinates minus C0, F1 has coordinates C, 0, and P has coordinates XY. So call this one equation 2. So you say using distance formula, a distance formula for 2 points in the plane, then equation 2 becomes, so this equation, the distance from F2 to P, so it's simply square root X minus C, so it should be X plus C squared plus Y minus 0 squared minus square root of X minus C squared plus Y minus 0 squared. And then this must give us the right-hand side is plus or minus 2A. So to simplify this expression, so remember this is the same thing as saying square root of X plus C squared plus Y squared minus square root of X minus C squared plus Y squared equals to plus or minus 2A. So to simplify this equation so that we do away with the square root signs, take this term to the right-hand side so that we have square root X plus C squared plus Y squared equals to, now, this will be now positive, so we'll have plus or minus 2A plus square root of X squared minus C, X minus C squared plus Y squared. So that's step 1. Then next, squaring both sides. We get, so left-hand side, they just remove the square root sign. So we have X plus C squared plus Y squared. And then this will be, remember this is the same as writing square root of X minus C squared plus y squared, and then plus or minus 2a squared, which will give us x squared plus c squared plus 2cx plus y squared equals to square of this one be x minus c squared plus y squared, and then plus, so remember plus or minus, when you square it, you just get positive. So 4a squared, and then this plus or minus be now minus plus. So minus plus or minus 4a square root of x minus c squared plus y squared. Remember, I'm just using the fact that a plus or minus b squared is usually given by a squared plus b squared plus or minus 2ab. So that's what I'm using to get the answer here. So this will give us x squared plus c squared plus 2cx plus y squared equals to x squared plus c squared minus 2cx plus y squared plus 4a squared plus or minus 4a square root x minus c squared plus y squared. So this and this cancels, this and this cancels, but you can't close in this one because they have opposite signs. So taking this, then also y squared and y squared. So take this to the left, we'll have 4cx, or this plus this, equals to 4a squared plus or minus 4a square root of x minus c squared plus y squared. Take, so you see 4 is common, so dividing through by 4, say divide by 4, divide by 4, divide by 4, we get cx equals to a squared plus or minus a square root of x minus c squared plus y squared. So which will give us, take this one to the left, so we'll have cx minus a squared equals to plus or minus a square root of x minus c squared plus y squared. Now also to move this one, you square both sides. So squaring both sides, we get, so we have cx minus a squared square. So when you square plus or minus, just get square. So this will be, remember when you have a b squared, ab power n, it is a power n, b power n. So when I square this one, the square will affect a and also affect this one here. So I'll have a squared, and when you square this one, just get the what we have inside without the square root sign into x minus c squared plus y squared. And so I have c squared, x squared plus a. Now this squared is a power 4, and then minus 2c a squared x equals to a squared into square of this one will be x squared plus c squared minus 2cx plus y squared. When you open brackets, so we have c squared x squared plus a power 4 minus 2c a squared x equals to a squared x squared plus a squared c squared minus 2 a squared c, and then x, and then plus c plus a squared y squared. Let's see which terms will cancel here. Now you see this one, this term and this term are the same and they have the same sign, so they cancel out. So we'll have bring all those terms with x and y on the left, and then take terms without x and y to the right. So we'll have c squared, x squared, bring this one to the left, minus a squared, x squared. Bring this one, we'll have minus a squared, y squared, equals to, now we have a squared, c squared. Take this one to the right hand side, will be negative a power 4. So common here is x squared, so you can say c squared minus a squared, x squared minus a squared, y squared equals to, common here is a squared, so a squared into c squared minus a squared. And you see from this diagram, distance from the center to F1 is greater than the distance from the center to V1. So C is greater than A. So it tells you that when you square C, it should also be greater than A squared. And this means that C squared minus A squared is greater than 0. So these are positive value. And then difference of squares, then we can just fix this one to be another square. So we say, let b squared be given by this difference, c squared minus a squared. This, we are choosing this one because we are sure that this difference is a positive value because c is greater than a. C is greater than a. So this means from this step, we'll have b squared x squared minus a squared y squared equals to a squared, this is b squared. I remember a is a positive number, b is a positive number. When you square them, they are just still positive numbers, and then multiply the squares, we still get the positive numbers. So therefore, because they are not 0, then we can divide through by this value on the right hand side. So dividing through by a squared, b squared, a squared, b squared, a squared, b squared. So you'll say dividing by a squared, b squared, we get, so you see this and this will cancel out, this and this will cancel out, and then this will give us 1, this will give us 1. So it'll be x squared over a squared minus y squared over b squared equals to 1. So this is the equation of a hyperbola whose transverse axis is the x-axis. So, and then this is given by this one, this equation with b squared being the same as c squared minus a squared, and c is greater than a. So this is the equation of a hyperbola whose center is the origin and transverse axis the x-axis. So in the next session, we'll derive the equation when the transverse axis along the y-axis and the center is still 0, 0. So thank you.